Swayam Prabha. Digital India. Educated India.
So, what will happen? Cost curve will shift downward and catch locus will shift upward. Okay, catch locus will shift upward. So, this is what we have to understand the dynamics from the catch locus. I will go back to the diagram once again to understand the dynamics better. So, here what we are assuming that if the fishes are highly valued, obviously the revenue would be more, this revenue curve will be shift upward. Similarly, if the cost of extraction goes down because increase in stock, then this cost curve will keep on shifting downward, as a result of which this catch locus will shift upward. That is the point that I would like to mention here. Okay. So, catch locus will shift upward. So, that means the catch locus we will have different types of catch locus in this dynamic setup. When there is a change in cost of extraction or cost of harvest, when there is a change in price in the fish market, that will give an upward push to this catch locus will shift upward. Now what we will do? Now let us superimpose the catch locus on the growth path that we have discussed earlier. The growth function discussed earlier. Okay. So, what is the growth function? What we will do? We will go back and draw the diagram once again. So, let us do it in the next page. So, this was our diagram, if you recall. This was our diagram. In the x axis, what we are measuring? We are measuring stock, and in the y axis we are measuring growth, which is a function of x and t, and also rate of extraction, and then this was our growth path. Okay. This is x c, this we call is x minimum, x mean. Okay. Now, in this diagram, and this is the maximum, this is x MSY, that means stock corresponding to maximum sustainable yield, and this is I will say maximum sustainable yield. Now, what we will do? We will superimpose the catch locus in this diagram. There would be various type of okay. So, catch locus is shifting upwards. Starting from here, we can understand catch locus is shifting. Let us say this is the dynamics. So, that means the moment it shifts, why the catch locus is shifting? For two reasons. Fishes are highly valued, and then the cost of extraction is going down, as a result of which the optimum extraction is becoming more and more. Okay, because how we have defined catch locus? Catch locus is the optimum rate of harvest on those cost function. So, obviously, when the cost function shifts downward, fishes are highly valued, then catch locus will shift upward. That is what is happening here. Okay, that is what is happening here. At steady state, what we know, that x dot t equals to g of x t minus y t equals to 0, and also rho dot t equals to r into rho t plus del c dot del x t minus rho t into del g dot del x t, this entire thing equals to 0. These are the two things that happens. So, any intersection between the catch locus and the growth locus defines a steady state. But all steady states are not stable. So, what are the stable state? When catch locus intersect the growth locus we get a stable steady state. Okay, we get a stable steady state. Okay. So, all this intersection point where the growth locus is actually intersecting with the catch locus, these are all economist optimum. Okay, these are all economist optimum, right? So, let us assume that x1 is the sustainable stock where growth rate and harvest rate is same. Okay. Let us say that all this intersection, let us say this is x1, let us say this is x1, this is let us say x2, okay. This is let us say x2, then it is x MSY, this is let us say x3, and this is x mean, okay, this is x mean. So, let us say that at points like x1, x2, x3. At point x1, x2, x3, what happens? Growth rate equals to harvest, rate of harvest. Rate of harvest. So, all these points are optimum for an economist. Because economist optimum is defined by the steady state where growth equals to rate of harvest. G of xt equals to yt, x dot t equals to 0. Okay. But how is the biologist optimum defined? Biologist optimum, however, biologist optimum the biologist optimum is defined as x MSY. X MSY, right? So economist's optimum may not always be same as the biologist optimum. Because biologists have only a single optimum, while economists have many optimum point. All these points x1, x2, x MSY, x3, all these are optimum for economists, while biologist optimum is only x MSY. Interestingly, through this x MSY is also a point where a growth locus is intersecting with the catch locus. So, that means if economist's optimum happens at this point, at the peak of the growth, then only biologist optimum will converge with that of the economist one. Please try to understand what I am saying. There are multiple optimum points for the economists where growth is actually equals to harvest x1, x2, x3, they are all economist optimum. But there is only one point where economist optimum and biologist optimum is converging to each other. What is that? X MSY, because it is derived from a point where catch locus is intersecting the growth locus from the below, and that is happening at the peak of the growth locus also. Then from here we can actually derive the condition for economist optimum and biologist optimum to converge each other. Okay. So, conditions for biologist optimum to converge with the economist one. And how we will derive the condition? Same steady state equilibrium rho dot T equals to R into rho T plus del C dot del xt minus rho T into del G dot del xt equals to 0. Let us assume that R equals to 0 and del C dot del xt is also equals to 0. Okay. So, that means for the entire thing to become 0, therefore, so for rho dot T equals to 0, we need del G dot del xt to be 0, because rho dot T cannot be 0. Okay. Now, this basically implies at the point where I will say that where growth rate is 0. So, that means this is the point where peak of the growth locus, okay, peak of the growth locus is happening. And if we have the peak of the growth locus, then only economist optimum is converging to biologist optimum. Hence we see that if R equals to 0 and del C dot del xt equals to 0, then and only then and only then biologist optimum and economist optimum economist's optimum converges with the biologist one. Okay. Now, that means basically what we are saying, that economist optimum will converge with the biologist optimum when there is no discount rate and there is no stock effect on the cost of extraction. These are the two conditions. Now, in this condition, let us say that let's assume xt is actually greater than x MSY. XMSY. So, since del C dot del xt is actually 0, there is no point in holding a stock which is greater than XMSY. Okay? There is no stock effect. Why should I hold more stock than what is XMSY? So, the stock will come down to XMSY only. Okay? Right? Hence, no benefit from more stock and extra stock. So, more benefit, there is no benefit for holding extra stock. So, that is why it is more rational. So, it is more rational to harvest more and stock will come down to XMSY only. So, if at any point of time the stock is more than this, since there is no stock effect on cost of extraction, it is better to harvest more and more, and the stock will come down to this. Similarly, if R equals to 0, then what happens? Then that means that implies there is no discount rate, no discount. So, it is better to consume today than preserving it for tomorrow. So, stock reduced to XMSY. But this condition, if you see, both these conditions are highly restrictive. That means it is difficult to assume that there is no stock effect on cost of extraction. Similarly, it is difficult to assume that there is no stock effect actually, there is no discount. So, these are all very restrictive condition, and as a result of which we say that actually there is economist optimum will converge to the biologist optimum only in this very specific scenario. Okay? In this very specific scenario. We will discuss the remaining thing in our next class. Thank you.